So in the last video, we learned about piecewise functions, where the graph is actually broken up into separate little pieces. One of the most common types of piecewise functions is known as the step function. We also call it the greatest integer function, and it looks like this. First of all, this is the notation. We have these double brackets like this, and then an X in the middle. So it's like a big bracket, and then you put like an extra line in it. All right, so whenever you see that symbol, that stands for the greatest integer function. What it does is it basically takes the decimal and it chops it. Okay, so known as the greatest integer function, and it looks like this. So like I said, it takes any decimal and just chops it off. So if you plugged in 0, there's no decimal to chop off, so it's just 0. But if you plugged in like 0.1 or 0.2 or 0.3, it chops off the decimal and it just plots it at 0. Once you get to 1, it gets plotted at 1. All right, so now everything here gets plotted at 0. Because if you were to chop off the decimal, the integer part that remained would just be 0. And then what you do is you leave an open circle here to show that it gets really, really close. Like even if you put 0.99999 repeating, if you chopped off that decimal, it would be plotted at 0. So as soon as you hit 1, the integer portion of it is 1. And then at 2, the integer portion is 2. So everything from 1 all the way to 1.9999 repeating has an integer portion of 1. And then we put an open circle here. And then we do the same thing from 2 to 3. 2 to 2.999 repeating, the integer portion of that number is just a 2. Like if you chopped off 2.8, if you chopped off the 0.8, it would just be 2. 2.9, if you chopped off the 0.9, it would just be 2. And then it jumps up to 3, and you just keep this process going for every single integer. And it does the same thing back to the left as well. If you chop off the decimal portion, you just get this stair-stepper function. So we call it step function. We also call it, like I said, the greatest integer function. All right, so an example of this. Let's say a recycling company pays $5 for every full box of newspaper. They do not give money for partial boxes, meaning if you have 1.5 boxes, they still only give you $5. All right, so we're going to draw a graph. So first of all, we don't include the negative portions of the axis because you can't have negative newspaper or negative money. Okay, so this axis is going to be the number of boxes, and then this axis is going to be the amount of money. All right, so if you have 1 box, 2 boxes, 3 boxes, 4 boxes, 5 boxes, label those on there. Okay, so if you put anything less than a full box, you're not getting any money. If you don't put out any newspapers, you're not getting any money. And if you don't put out a full box, you're not getting any money. But as soon as you fill that box, you get $5 right here. So this would be an open circle because as soon as you hit 1, it jumps up to 2, or to $5, I'm sorry. And then if you have like 1.5 boxes or 1 3/4 of a box, you still don't get anything more than $5. You don't get more money until you hit that second box. As soon as you fill a second box, you get $10, which means this is an open circle. Okay, if you have 2 1/3 boxes or 2 5/8 boxes, none of that matters until you actually hit the third box. Once you fill a third box, then they give you $15. And it jumps up to this point right here. So it looks exactly like that stair-stepper function. It's just kind of going in increments of 5. Okay, so as soon as you hit that fourth box, then they give you $20. So the graph jumps up here. But then it doesn't matter how much of a fraction of a box you fill until you hit that fifth, then you jump up. And the graph is just going to keep going like that. If you don't have a full box, you're not getting any more money. And as soon as you fill that new box, it jumps up to the next amount. Okay, so that's what the stair-stepper function looks like. When you guys are asked to plot these, you're just going to do them in your calculator. So let me show you where some of these buttons are. So the way that this one works, let me show you. Let's do add page and add a graph. So that's the second option. Okay, when you plot the greatest integer function, if you hit this little button next to the 9 where all the weird looking symbols are, they have, oh, let's see, they don't have it in here. All right, escape. Let's just type it in. If you type in INT, it recognizes that as the integer function. And then whatever you want, you put it in parentheses. So you put an X and hit enter. Okay, so the stair-stepper function looks just like that. All right, so anytime in your homework that you are asked to plot a stair-stepper function, you're not doing it by hand, you're just going to do it in the calculator. All right, so you might have to plot something that looks like this. Like integer, and then maybe there's a +3 on the outside. And you just graph it on your calculator and then draw what it would look like on your homework. Okay, so that's our second type of special function. Our third and final type is known as an absolute value function. And we will do a lot more with this absolute value function in both sections 2.7 and 2.8. But for now, we're basically just plotting the absolute value stuff that we learned about in 2.4 and then did some more with, or I'm sorry, in 1.4 and then did some more with in 1.6. All right, so our function looks like this. F of x equals the absolute value of x. And we know how absolute value works. If you plug in a positive number, it comes out positive. If you plug in a negative number, it still comes out positive. Okay, so it's going to look like this. Let's make a table. X, Y. So here's a great number of values to use. If you go -2, -1, 0, 1, 2. So you guys are going to be making some tables in this section. These are the x values that I want you to plot. So -2, if we plug -2 into this function, absolute value of -2 is 2. Now plug in -1. Absolute value of -1 is 1. Now plug in 0, we're just plugging them all into this function, finding the y value. Absolute value of 0 is 0 because it's not any distance away from itself on the number line. Then 1, absolute value of 1 is 1 unit from 0. And 2 is 2 units from 0. So we're going to take those 5 points, we're going to plot them. I'm going to show you what this graph looks like. Okay, so start with the point -2, +2. So -2, +2 is right there. Next, the point -1, +1. So from the origin, -1, +1. Then the point 0, 0, right at the origin. Then 1, 1, so over 1, up 1. And 2, 2, so over 2, up 2. So these are the 5 points. And so when you connect the dots and keep the graph going out to both sides, you'll notice that it just has this V shape. So it's like this part of it looks like a normal line. And then when you get over here, that line flips because it gets flipped above the x-axis where everything is positive. Okay, so that's what your absolute value graph looks like. It looks like a V. The normal one is centered right at the origin, but we're going to do some examples here where we make some changes to it. So the way that you guys will be graphing these in your homework is just by plugging in to this table that I gave you right here. All right, so an x, y table, just use those 5 values, -2, -1, 0, 1, 2, and you just take those 5 values and sub them in for x into this equation. Okay, so absolute value of -2 minus 2. All right, so -2 minus 2 is -4. -4 is 4 units away from 0. Okay, so I plugged in -1 for x. -1 minus 2 is -3, which is 3 units away from 0. Now plug 0 into that absolute value. 0 minus 2 is -2, which is 2 units away from 0. Now plug in 1. 1 minus 2 is -1, which is 1 unit away from 0. And plug this in. 2 minus 2 is 0. Okay, so let's plot what we've got here. Okay, so we have the point -2, 4, which is right here. -1, 3. -1 up to 3. 0, 2 would be right on the y-axis. 1, 1 is right here. And the point 2, 0 is on the x-axis. So now this doesn't look like our V shape yet. So let me show you what happened if we plugged in just one more value. Say we plugged in a 3. 3 minus 2 is 1, which is 1 unit away from 0, and that's when the graph turns around. So now we can plot like this. There's the left side of the V, and the right side is just going to keep going up. If I plugged in 4, 4 minus 2 has an absolute value of 2, so it's just going to keep going up from here. So this looks the same as this. It's just like I picked it up and moved it over here. All right, one last one. We're going to make the exact same table, just plug that in. Okay, so take those 5x values and just take turns plugging them into the equation. Okay, so remember with absolute value, I can't distribute that negative. I take the absolute value, then I make it negative. So negative 2 is 2 units away. Make it negative. So negative 2 plus 1, which is negative 1. So I'm going to start plotting as I go. So negative 2, negative 1 is my first point. Then plug in negative 1, negative absolute value of negative 1 plus 1. So this is 1, which means the whole thing is negative 1, and then plus 1 gives me 0. So negative 1, I'm right on the x-axis here. Now plug in 0. Negative absolute value of 0, that's just 0, plus 1 gives me 1. So I'm right here on the y-axis. Plug in 1, negative absolute value of 1, plus 1. So this is negative 1, plus 1 gives me 0. So 1, I'm right back on the x-axis here. And my last one, 2. Negative absolute value of 2. Absolute value is just 2, so the negative absolute value is negative 2. So negative 2 plus 1 is a negative 1. So that is my last point on the graph there. So you can see the V shape. Notice that the V shape is upside down. We'll talk about why exactly that happened in the next section. Notice it's also 1 unit up. Our original graph started at the origin. All right, so that is your absolute value and step function stuff.